Hi, everybody. My name is Eliza Lawrence, and I'm a sophomore here at the University of Oregon studying biochemistry and journalism. This summer, I received a FIRE grant through the Center for Undergraduate Research and Engagement and worked with Dr. Ellen Peters at the University of Oregon and Dr. Brittany Schutz Reinhardt at Ohio State University in the Cognitive and Affective Influences in Decision-Making Lab. Our lab is interested in studying how numeric and non-numeric information is processed by individuals and how communication techniques can be altered to better help people make judgments and choices. I spent the summer looking at how presenting vaccine side effect information numerically versus non-numerically affects people's intentions to receive a vaccine. Most often, vaccine side effect information is communicated in a qualitative manner, meaning when you go to the doctor or look on the CDC's website, you'll see a list of possible side effects you may experience after receiving a vaccine, but we'll have no idea what percentage of people experience them. Previous research conducted by Dr. Peters concluded that presenting adverse side effect information numerically for prescription drugs increased risk comprehension, levels of uptake, and adherence of prescribed medication. The purpose of my research was to determine if presenting side effect information numerically increases risk comprehension and willingness to receive a vaccine. To answer this question, I designed a survey with two parts. The first survey included questions on objective numeracy, which is a series of math questions that can help us understand how numerate and comfortable people are with numbers. The survey also included questions on past behavior regarding vaccines, including COVID-19 and influenza. The second survey, given 2 weeks after the first, randomly assigned participants to one of 4 conditions. Each condition gave a brief overview of the vaccine and the disease it was designed to protect against, but varied in how much information was given about side effects. We based the list of side effects and the likelihoods of the vaccine on the first dose of the Pfizer COVID-19 vaccine, but in our study, the name of the vaccine and the disease were unnamed. The first condition possible for participants to be assigned to only included the list of side effects, so only the rightmost column here. This almost exactly resembles how the CDC website presents COVID-19 side effect information. The second condition listed the list of side effects in the corresponding likelihood as a risk label, so the middle and right column here. The risk labels were based on European Union labeling standards. For example, anything that has a likelihood of 10% to 100% is labeled as very common, and anything greater than 1% to 10% is labeled as common. The third condition listed the list of side effects and the percentage of people who experience them, so the left and right columns. Finally, the fourth condition included the list of side effects, the percentage of people who experience it, and the corresponding risk label, so all 3 columns. All participants were asked the same set of questions after being assigned a condition. These included questions about how likely they would be to receive a vaccine, as well as the reasoning for their selection. We also asked about participants' risk comprehension for the vaccine by asking what they thought the likelihoods of experiencing each side effect was. Finally, the survey had questions on participants' understanding of risk labels. We had 595 participants complete the surveys on Mechanical Turk, an online survey platform. At the beginning of the study, we hypothesized that presenting numeric side effect information with or without risk labels will result in less risk overestimation and more willingness to receive the vaccine, as compared to presenting only non-numeric side effect information. After receiving the data, we began the analysis using a statistical software called SPSS. The analysis is still in its early stages, so I'll just be highlighting 2 of our findings today. We determined how vaccine intentions varied through the 4 conditions, as well as people's comprehension and understanding of the EU risk labels. Our first finding is that people who were given numeric information in conditions 3 and 4 had higher intentions to vaccinate over people who were given non-numeric information in conditions 1 and 2, seen here. Our second finding was that people continually underestimated what verbal label would be used for a side effect. For example, we asked people, if the percentage of people who experience a side effect is 7%, what do you think it would be labeled as? On average, people believed that a side effect of 7% would be labeled as rare. According to the labeling standard, it would be labeled as common. Similarly, when asked about a side effect of 0.1%, people labeled it as very rare. According to labeling standards, it would be labeled as uncommon. From this, we can conclude that without numeric information, participants may overestimate the likelihood of side effects. In the coming months, we will complete further analysis on how risk comprehension varies across the 4 conditions. We will also use the data on objective numeracy mentioned earlier to examine the interaction with the 4 conditions and predictions of risk comprehension and intentions. Further, we will explore the same effects of comprehension and intention after controlling for prior vaccinations and demographics. I'd like to thank Kier for providing the funding for this research experience, as well as Dr. Peters, Dr. Schutz-Reinhardt, and the other members of the Katie Lab for their mentorship.